Hello, everyone. Many organizations find themselves today considering optimization and modernization of their existing application landscape to include the benefits and unique offerings of generative AI with the view to transform user experiences they build for their own customers. But they might find the journey rather challenging and difficult to embrace the new trends while also having to think about ethical considerations and responsible use of the same technology. My name is Amir Amicevic. I work for Amazon Web Services as a solution architect, and today I will showcase a rather unique use case on how to build and power accessible solutions with generative AI and eye gaze direction detection. Welcome to the presentation, and thank you very much for being here. According to the UK's Office of National Statistics, there was 11 million disabled people using the internet in year 2020. Consequently, this use case is about building a solution and helping disabled people with a solution where they can interact with a generative AI-enabled application simply by looking at the screen using their eye gaze. That makes generative AI much more inclusive, and in being so, it helps disabled people to access the benefits and unique offerings of the technology. So today I will showcase how we can build inclusive solutions on AWS using the fusion of traditional ML and the new AI services. I will show you the demo of the application, which hopefully will be very interesting to see. That will be followed by a deep dive of the architecture so we can see how it all hangs together and how it works. And in the end, I shall conclude today's session by talking about how I can help you and enable you to build your accessible inclusive solutions on AWS. Now, this story has a rather personal resonance to me. Let me tell you about David. By the way, this is not David on a picture. This is just to show the working environment to my friend. David was a friend and a colleague, and we used to work together some time ago. He was a disabled person, a wheelchair user with speech impairment and limited mobility. He was a truly wonderful character, and one of his favorite things to do while we were in the office was to joke at my expense, especially when my football team was getting beat. And that created a rather unique bond between the two of us. On top of that, he was an excellent SQL developer, and he used voice-assisted technology to help him write his SQL code. The technology did work pretty well, and it enabled him to deliver his work. But at the time, I could also see that it made mistakes, it was error-prone, it led to frustration, and it failed him on inclusion and accessibility side of the things. That has made a big impact on me, so I have embarked on a journey of building a proof of concept application. Our inclusion, diversity, and approach is embedded in the principle that inclusion must come first before we can have fully diverse and equitable AWS and the world. So when I found out that in May 2023, Amazon Recognition released a new upgrade to the service that includes the ability to track the user eye gaze near real time, I immediately thought about David and how he could appreciate a solution that's based on capturing users' eye gaze and mapping that to a particular screen on the control on the screen that they're currently looking at. So that would enable the eye gaze to be a primary driver of the communication between the human and computer application. That was one aspect of the solution. Another aspect of the solution is to democratize generative AI and to make it more inclusive for disabled people, given the benefits that it can bring when used. So far, I've mentioned Amazon Recognition a few times, so let me tell you about this service, how it does, what it does and how it works. So it's a vision machine learning service that makes it easy to enable audio and video analysis in your application. It can detect faces, it can detect objects, scenes, activities. It can detect and delete inappropriate content. It can also work out emotional insights simply by analyzing facial expression. And what we are really interested in, it can deliver the eye direction attribute. And that's what we are going to use today in the demo. The eye direction attribute delivers two values, which is the yaw and pitch values. The pitch value represents the eye movement around the x-axis, while the yaw value represents the eye movement around the y-axis. And the values range from minus 180 to plus 180. The service also delivers a confidence score that ranges from 0 to 100, where a high value of the score represents the service's belief that the value we are getting is actually close to true. So, having now explained what the service does, it's about time to see the demo of the application. Here we see the application that I humbly called iGen AI, eye gaze expression with generative AI. This is the first screen, so we shall enable the application. This video will be about 4 minutes. So what we see here is two main components. This is me standing in front of the computer holding a camera, and you can see my eyes, and we see the viewport. And the importance of this viewport is that we need to transform the values that we get from the service, minus 180 to plus 180, to the coordinates of this viewport. That's why we have top, right, bottom, left, and center. So soon you will see that I will start clicking on these buttons, and I will be focusing my eye gaze on these buttons. So the viewport can actually understand how it can calculate the point that we're looking at. So you can see my eyes are now moving. I'm going to click on the left, and then my eyes are moving to center. Click on center, and now the red circle that you see in the middle represents the point of the screen that I'm looking at. So at this point, the application is calibrated, and we can start using it. It has pre-approved points, conversational topics that we can use in this instance, ranging from art, music, sport, and so on. And I am now looking at all the options. So going from right to the left. And as I look at these options, they get selected. And I'm not using my hands. This is all just driven simply by looking at the screen. And you can also, if you look at the image, you can see my eyes moving from one direction to other. So now if I keep my eye gaze on a particular option for 2 or 3 seconds, this will select this option and create a prompt that gets sent to the generative AI backend. That creates the text at real time that we see displayed in the middle. But how do we make this easier to use? I run key insights extraction from this text and display that on the big boxes. And now these big boxes will also be, the user will be able to simply look at them, and once they focus on something that they want to get more information from, they can just look at it. At this point, I wanted to find out about First Railway System. And again, we follow the same practice. There's the information received from the generative AI large foundation model. Then we run key insights extraction. We see all the key insights extracted from this text. And now I want to focus on steam locomotion. And again, we follow the same process. The next is the first passenger train, which will hopefully get selected. It takes about 2 to 3 seconds for the back end to send us the text generation back to the front end. Now I would like to see about modern infrastructure. And everything that we see on the screen simply follows this breadcrumb of history, railway systems, steam locomotion. So we can also see how this can be used to further deliver personalization as part of the application. And I'm now just reading the text, so we can see the red circle following my gaze. I'm now focusing on communication networks. And yes, the back end sends us the data about communication networks. I'm slowly reading about that, but then I also could continue looking around and select what I wanted to select. So let's recap. So we got two components. We've got the screen that captures the video. That video is dissected into a sequence of images. Images are sent to the back end, and that creates the text generation. We display that on the screen. We run the key insight extraction, and we then follow that process. So let's see how this works. This is the part where we get to use the Amazon recognition to tell us the point on the screen that we are looking at. So the web user that sends the image to Amazon API Gateway, the service that we use to build the APIs at scale. Gateway speaks to Lambda, and the Lambda creates a few lines of code, asks recognition to give us the yaw and pitch values and confidence score. And that goes back to Lambda Gateway and to the front end. Once we have that, we then work out the prompt creation. And when the prompt is created, we use the same line of execution. That goes to Gateway. Lambda goes to AWS Lambda. And Lambda speaks to Falcon 7B endpoint on SageMaker. Falcon 7B is a large language foundation model, and that's been trained on SageMaker as such. And when we get text created, it goes all the way back to Lambda, API Gateway, and to the front user. If you remember from the application, all those big, large boxes that were holding key insights were created by the service called Amazon Comprehend. And Amazon Comprehend is a natural language processing service that does many things such as document analysis, topic of documents extraction, key insights extraction, entities extraction, and so on. It can also be used to deliver the sentiment of your product user reviews, for example. And in this instance, we use Amazon Comprehend to give it a generated text input from the Gen AI large language foundation model and ask it to give us key insights of that. It follows the same path. The HTTP request call is created to Amazon API Gateway, which runs down serverless Lambda. Lambda gets in touch with Amazon Comprehend, and we get our generated text returned to Lambda Gateway and the web user. And now, this is a complete architecture of the system, and one of the main parts of this is just the principle of simplicity. There isn't really that much going on at the back end. So we see, I think, 5 unique AWS services. We've got recognition, SageMaker, Comprehend, a Lambda that's used in each scenario, and Amazon API Gateway. Now, this could, of course, be, if this application was to be worked further on and delivered into a final product, this, of course, could be made much more complicated. But this is the main tenet of this demo, that it's based really on simplicity. So how can this help you? To me, innovation personally comes as something, when you think outside the box, and when you're not afraid of trying different things, of failing and then restarting again, thinking outside the box, pushing the boundaries. And I quite often find these ideas of how to build something, minimal delivery product, when I'm in the gym, exercising, or when I'm outside running, doing my 10K, because it really does help. It takes your mind off the fact that you are running, you're getting tired, you want to stop, but you don't want to stop. And then thinking about ideas really do help, because when you realize, wow, I've already done half an hour of running, and then it feels not only that you've been productive for your health benefits, you're also working on things that you really like and enjoy. So when I heard that Amazon Recognition released this upgrade of its service and made it available to us engineers, developers, architects, to capture the user's eye gaze in near real time, I had a vision of this application that had a large number of boxes on the screen, and where each box represents a conversational topic that drives the conversation between the front end and the generative AI-enabled application purely by using the user's eye gaze. And that was rather compelling to me, because that use case was quite unique. It made it different from your everyday typical chatbot application. Also, being a fusion of different ML and AI services, it delivered more. It delivered richer set of features, and it also enables generative AI to be more inclusive to disabled people, and it gives them the access to this technology and make it easier for them to use this technology. And how can this be of help to you? So if you or the organization that you work for are currently undergoing similar projects, building inclusive solutions, or if you're at a point when you are thinking about starting this journey, I would be happy to share my experiences and challenges that I've encountered while building this proof of concept. You've seen the back end of this demo application. It's fairly simple. There isn't that much going on, but the most challenges that I've encountered while building this was on the front end, trying to map the values that I get from the back end and make them work on the screen. And you should have seen the first version, the second version of this. It didn't look anything like it. That red circle that was on the screen was quite manic. It was all over the place. And at some point, I thought to myself, should I just drop this or should I just continue? And I'm glad I didn't choose the first option and I went with the second option. So I will be happy to speak to you about that if you are thinking about building a similar project. On the next slide, you will see my LinkedIn details as well. And please feel free to contact me on LinkedIn. I'd be happy to help you out. I also hope to get a blog on AWS written on this subject at some point after reInvent. So if you follow me on LinkedIn, you will be notified, and we can certainly stay in touch. So that brings us to the end of this presentation. I feel really privileged and happy to be able to stand in front of you here today and talk about a subject that means a lot and show you the work I've been busy over the last few months, let's say it like that. Thank you very much for being here, and I hope you found this worthwhile, and I wish you good luck on building your own inclusive solutions. Thank you.